Hello, this is Rick Powers from Western Technical College for Basic Statistics. Lesson number 15, Discrete Probability. We now connect two subjects, frequency distributions and probability. This develops a central idea of statistics. The purpose of statistics is to know what to expect. Here's a table showing the number of cars that people own and how frequent those numbers occur. The number of cars goes from 0 to 5. The frequencies are in the second column, and then the relative frequencies are in the third column. Recall that the definition of observed probability is the same as the definition of relative frequency. The probability is equal to the specific set divided by the total. So now we change our perspective to consider the percent for each category to be an observed probability of a data value. We call this a discrete probability distribution since the data values are all whole numbers. Later, we will have continuous probability distributions where the data values can be decimals. Note that we can describe the concept of unusual value by specifically indicating any data value with low probability, especially below 5%, and often at the low or high side of the data values. Caution, do not use the empirical rule with discrete probability since we already know the percent for each data value. Here is a revised table. Note that the number of cars is now labeled with X and the percentages are labeled P of X. This is a very important step. It is vital to know what is actually being measured in the situation. The number of cars is what's being measured. It is the variable in the situation. Each data value has a probability, but the actual data value is not the same as the probability. Our next task will be to find the mean and the standard deviation for this data set. Even though these numbers will give us important information, we do not want to apply the empirical rule. We already know the percent of data from the second column of the table. The process of finding the mean and standard deviation for this type of data set can be tedious if using the formulas. However, technology can be applied to make the processes much easier, quicker, and more accurate. Information will be provided for you in separate class notes about technology options. Finding the mean is fairly easy. We take the value of the variable multiplied by its probability and then find the sum. Here's the formula. Mu, or the mean, is equal to the sum of the variable X multiplied by the probability of X. The standard deviation is more complicated, and the formula is not needed when we have the technology. Here are the values. The mean, mu, is equal to 1.9. The standard deviation, sigma, is equal to 1.06. If the mean is 1.9, the standard deviation is 1.06. Note, these are the values for the mean and standard deviation of X, which is the number of cars per household. This is the result of 50 total measurements. The mean is 1.9, standard deviation 1.06, and looking at the table, this should make sense. 2, quote unquote, is in the middle, and between 1 and 3 is most of the data. This process is very important to business decisions, such as for a ski shop. The weather could be warm or cold or snow. The probability of each of those, the probability of being warm is 10%, probability of being cold is 70%, and the probability of snow is 20%. Then the profit in dollars for each of these events, if it's warm, you lose money. It's a negative 2,000. If it's cold, then your profit is 1,000. If it's snowy, Then your profit is 5,000. For this situation, the mean is called expected value. That is a poor choice of words, however, because it's not the value that's expected from the event. It is the long-term average of the results. We can also call it the weighted average. If we find the weighted average, that number comes out to be $1,500. So our long-term expectation of profit is $1,500. However, it's also important that a person in this situation is able to handle a loss of $2,000, since it's not an unusual event. The implications of this process are huge. All of insurance, social media, and advertising are based on the probabilities of events. If you were to study this in graduate school, you would have tons of job offers and high salaries offered to you. And when you become successful, please send me a note so I can share in your glory. End of lesson 15.